So now let's talk about some properties of definite integrals. So the first one, if f is defined at x equals a, then the integral from a to a, f of x dx, is 0. So remember that this integral corresponds to area, but here, if you're starting off at x equals a and ending at x equals a, there's no area for you to calculate. So that's why this integral is 0. And then the second says if f is integrable on the interval a to b, then the integral from b to a, f of x dx, equals negative the integral from a to b. So if you flip the order of your bounds, if you flip the numbers, you're going to get this minus sign here. And then the third property, if c is between a and b, then the integral from a to b is the same thing as the integral from a to c plus the integral from c to b. So it's easiest to see this if you think in terms of area, right? So here's maybe I have a function that looks like this, and I want the area from a to b. So I want the area of this whole shaded in region. And so now I have a c in the middle of a and b. And so what I do is split it up into this area plus this other area. And so if I add up those two areas, it'll give me the area from a to b. So let's put these properties into use. Let's look at an example here. Evaluate each integral. So the integral from pi to pi of sine x dx. So here, notice your two bounds here are the same. They're both pi. And so when they're the same, this is going to be equal to 0 using our first property. Let's look at another one, b, the integral from 3 to 0. So usually we like our numbers to be increasing, and here I have 3 and 0. So when I want to flip these, I got to put in a minus sign according to my property. 2 from up above. And we actually computed this earlier. So I'll say and what we got was 21 over 2 using area. All right, and then the last one we're going to do in this video, c, the integral from -1 to 1 of the absolute value of x dx. So here my function is, so maybe I'll just write y. It's y equal to the absolute value of x. So if I graph this region, if x is 0, it's 0. If x is positive, the absolute value of a positive number stays the same. But if x is negative, like -1, the absolute value would be 1. And so I'm getting really these two different pieces. And so what I'm going to do, because I want to find the area from -1 to x equals 1 here, I want to find these two areas here. I'm going to split this up into two separate integrals using property 3. It's the integral from -1 to 0 plus the integral from 0 to 1. And then in this first one, x is a negative number, so this is -x. And the second one, x is positive, the absolute value of x, so it would just be x. So then you compute these two integrals here. So maybe we just add up the two areas of these triangles here. So the area here would be 1/2 base times height. The area of this triangle right here would be 1/2 base times height. So I'm getting 1 for this area here.